So still talking about area. This whole chapter is about area and perimeter. So we're talking about area of trapezoids, rhombi, and kites today. Okay? So trapezoid. Remember trapezoid looks like this thing. What makes a trapezoid a trapezoid?
It has two pairs of parallel sides, and each of the two pairs of parallel sides are congruent to each other.
Ooh, close to
One pair.
Okay, one pair of parallel sides. Right? So in this case, we have little tick marks there, or not tick marks, but arrows. Arrows tell us they would be parallel. So parts of a trapezoid, we have two bases for a trapezoid. Those are the two parallel sides. Remember, railroad track sides means parallel. That's a short symbol there. And the height is going to be the distance, or I should say perpendicular distance between the bases. Remember, upside down scheme means perpendicular. Means they have to make that right angle. Just like yesterday we were talking about height, they made that right angle together. The height has to be perpendicular between both the bases in our trapezoid. Okay? So our formula says area of a trapezoid is, so area equals half times the product, and multiply, product of the height and the sum of the bases. Sum means that. Okay, and I will note down here. So remember your order of operations, you have to add the bases before you multiply. Otherwise you're coming up with the wrong answer. Because they are in parentheses, you have to do them first. Okay? So if I'm looking at example 1, this is approximate the area of Arkansas by finding the area of the trapezoid shown. So I would first find what are the two bases.
What are the
So it doesn't matter if you call base 1 or base 2, but I like to label them just so.
How do we know that? Oh wait, you just choose the ones that have the two measurements that are the bases. The two parallel.
The ones that are parallel.
Oh,
These are going to be parallel. And usually when they say that it's a trapezoid, they're not going to put in little arrows that tell you that they're parallel. They're just going to assume that you know, since it says it's a trapezoid, that those are parallel even though they're not marked. Okay? So, I'm going to fill in our formula. We're going to have 1/2 times, what's our height?
Times 242.
Then we're going to add the bases. So 250 plus 190. Okay, again, what is our first step?
Add the bases.
Add the bases. So what's 250 plus 190? I'm supposed to set it down.
That would be 440.
440 times, and then I would take half of 242 just because it's an even number and it's easy to do that. So 121 times 440, which I don't know what that is.
53,240.
240? Okay. And go over to our table. Miles squared. This is the area. So that's a lot of square miles. I think it's mostly just area. Alright, so then it is on part B, it says that trapezoid on the area of the window. So what's our height?
18 inches.
And our bases would be the 20 and the 36. How do I know? Those are parallel. So again, I would take half of 18, which is 9. 20 plus 36 gets me 56.
56 times 9 is
Inches.
Inches. Okay, you have to do a couple more examples so does this make sense? Okay, so, part C is exactly like what we just did. They just don't give you a picture to look at. They just give you the information in words, but you guys can figure that out. Let's go on to example 2. It's asking us again to find the area of the trapezoid. Tell me, in this case, what are our two bases?
11 and 16.
Okay, 11 and 16. What's our height?
We don't know.
Why is it not 13?
Because that's not hypotenuse.
Right, it's not gonna be our perpendicular between the two bases, because it's at a slant. What are we gonna do?
I can have two on this
Let's
base.
say, Pythagorean theorem, okay. Problem though, if you get one side. Oh, we got a 13.
The thing we just did.
The thing we just did.
Extraneous solution.
No, we're not serious.
Oh,
I tried.
that one that you have to have the A and then B and then C.
Square.
Whatever it's called.
Quadratic formula.
Yeah, the quadratic.
Don't have an x squared in there or anything, no?
Can you give us a hint? What does it start with?
Let's just look at the picture. Look at the picture. Looking at what I've drawn, which I got in line in there, and I'm trying to look at this.
Oh,
3690. Is it the 3690? You know what you're saying? No.
This side has 290 degrees.
The other side is 9 degrees.
We can make
And
it.
then, no, it has 390 degrees. Do we use the, it has 4.
Never mind.
Do we use the,
We don't have to have.
couldn't we do like a rectangle so then it'd be 11 and 11 and then 5?
Yeah, 3's got it. Yeah, okay. So since we know from here to here is 11, and if I had drawn my line a little bit straighter, from here to here would be
11.
it'd be 11, but from here to here is 16, so how long is that little bit?
5.
5.
Ooh, next one.
Good job. Awesome. So now what can we do to figure out the height? Now we can do Pythagorean theorem, because now we have two sides. Good. Okay, so a squared plus b squared is c squared. What's our a, b, and c?
5 squared plus 6 squared plus 6.
Good. Remember, always hypotenuse we see. I hope you guys know that by now. Just remember. Oh, yeah. 4. So h is 144 is my favorite number. Right? I don't know if I told you this before. Hey, guys. 144.
Why? Why is it?
This is square root of 12. All right, so what's our height?
Wrong.
Oh, we just figured that out. What's our bases?
11 and 16.
Good, 11 and 16. So 11 plus 16 gives us 27. Half of 12 is 6. What's 6 times 27?
Oh, goodness.
162.
62. Don't forget to be squared. All right. If I'm looking at B, again, what do we not know?
We don't know the height.
We don't know the height, but we could draw it in here.
Oh, we could do the 30, 60,
We
90.
could do the 369, but however, just looking at this triangle right now, we have no idea what any of the sides are. What can we do?
3 and
There's 5 and
Yeah. Do the same things we did before. So from here to here is 5, and over here to here is 5. So 5 minus 7 is 2. And then we can use our 30, 60, 90. Do you want to do the rest of the problem, or does this make sense?
This makes sense.
6 times.
Okay. Are we ready to move on?
Yeah.
Yes.
Okay. Exactly like what we just did.
No, I hate run.
Okay, so for a rhombus or for a kite, they have the same formula. We'll get rhombus.
2 times 4.
Okay? And 4 congruents again. Both sides are, or both opposite sides are
Oh,
parallel
the
and
diagonal
close
to
number.
the diagonal to the lowest formula is triangle.
Sure, yes. Alright, so for the area of a rhombus or plane, again, we have the same formula. It says area is half the product of the lengths of its diagonals. So it's going to be half times D1 times D2. Notice, I didn't explain this on the last part, but notice that my 1 and my 2 are subscripts. They're down in this corner. Don't put them up here, because then they're exponents. We don't want that. we're just saying the first diagonal times the second diagonal.
Those called subscripts.
Subscripts. Yep. So remember, diagonals go from what to what?
Opposite corner.
Corner to corner. So this would be one diagonal. Say that's diagonal 1. And then our other diagonal goes from here to there. So that would be diagonal 2. Alright. So on example 3, it asks us to find the area of the kite. So we're going to say area is equal to half times one of the diagonals. Okay, you want to look at the horizontal or the vertical one first? Does not matter.
Let's go horizontal.
Alright. So if I'm looking from corner to corner, how long is that?
7.
And from corner to corner?
6.
6. So then I would think half of 6, because it's even, is 3. 3 times 7 gives us? 21 meters squared. Yeah, they're not so bad. Alright, for these, let's find the area of the diagonals that are 12 inches and 9 inches long. So we just plug it in. Half times diagonal 1 times diagonal 2. Again, I would take half of 12 because it's even, which is 6. 6 times 9 is?
Wait. How do you take half? Oh, I remember.
Okay. Yeah, don't take half of both of them, we just want to take half of them. If you wanted to, we could say 12 times 9 and then divide by 2, but we come up with the same answer. Okay, example 4, find the area of the rhombus. Ooh, these get a little bit more tricky. Why?
Because
You don't need no more than all the
the
diagonals.
diagonal.
Only a little guy. Yeah, 24. But if I draw this guy in, Jessica already told us, what do you remember about the diagonals?
It's 4 with 90 degrees.
Make a right angle. So let's just make a right angle over here. Okay, so what I'm going to do, I'm going to trace this guy. Okay, so we'll draw a little triangle. I'm pulling out this triangle. So I want you to draw a triangle off the side so we can mark it. Because in the picture it makes it a little bit more messy to figure out what we're doing. Doesn't have to look fantastically wonderful. Obviously, my tracing skills are not the best because it's kind of not straight, but that's okay. Okay, so on this triangle, what can we label? What do we know?
We know that the base is 15, and we also know that the goes to 45.
Well, we know that
The other side is 12.
yeah.
Okay. Why is it not 24?
Because it only happens at 29.
Good. It's only half. Okay, so we need to figure out along this side, and then we call it x. We have a right triangle, there's 2 sides.
There becomes 0.
Can't get away from that guy. It's gonna haunt you for the rest of the year. So again, 13 is our seeds, it's our hypotenuse. 25. B is. Okay, so how long is our other diagonal?
And
Aha, why is it not 5?
that's only one of the
Good, because we only found this part was 5, so we double it to get the whole thing is 10. Yep, so area is half times one of the diagonals, which is 24, and the other one that we just found was just 10, not 5. That's the most common mistake that I've seen people do. So then I would take half of 24 is 12, 12 times 10 is add another 0, so 120 squared. Okay, so example B is pretty much what we just did, because when I go through it, or do you feel pretty comfortable? Feel pretty comfortable?
Yeah.
Alright.
As long as you-